This is Leslie Howe, Howe-Two Software. It doesn't take very long for observers of Howe-Two Software to exclaim, "I've never seen anything like this before." That's because Howe-Two Software is kind of unique. Most software from education is template-driven. That means the producers created some sort of template that requires questions to be put in a certain format, usually multiple choice. Howe-Two Software is developed completely differently. You're looking now at the menu screen for high school. There's also a menu screen for elementary school. It looks like this. There's a third menu screen for middle school. These are just menu programs that draw on other applications. Every activity of Howe-Two Software is developed independently. There is no template. Each one is unique. Its format is designed to meet two needs, the needs of children and the needs of the subject matter at hand. I want to show you a directory here of some of the packages that are sold Howe-Two Software. If we look at the most traditional one, the high school course, How-To by Course, developed in 2009, you'll see that if we look what's put on the hard drive of the consumer, that there are folders in here. Each one of these folders has in turn many activities. Each one of these little icons here represents an activity. You can see for each activity there's also a text file beside it that describes how that particular program works. There are hundreds of these applications, and obviously the classroom teacher can't keep track of all of the hundreds of programs that have been written, hence the need for menu programs. Let's look back at the high school menu. When a teacher comes to the lab or pulls up Howe-Two Software on their machine, they're pulling up a menu. This menu can draw on any one of those folders that you saw previously. Teacher can usually tell what subject matter they're dealing with. If they're doing algebra with one unknown, they click here and get the submenu for that sort of program, or algebra with two unknowns, or x squared, or advanced stuff that's usually in the upper level courses, or calculus topics. If there were topics that we wish that students knew before they came to high school, that would be found in foundational topics. That would include number facts and just signed numbers and the sort of thing that we would, working with fractions, things we would hope that students would have. Obviously, these activities are crucial also to the middle school use of Howe-Two Software. The middle school menu is actually a sub-menu of this high school one, with topics that are like trigonometry and logarithms and calculus left off. Otherwise, the middle school menu is very much like this one. The elementary school menu is quite a bit different. As you can see, it deals with the concept activities because there's not as much overlap. There's spelling, and there's not as much overlap as between the high school and the middle school. Let's go back to this high school menu. Say a teacher decides that they're teaching graphing. Graphing, say, of conic sections. That's an advanced topic, so we would look down here and click on this advanced topic. Let me move the menu here a little bit. We can have conics graphing. And then comes a warning to the student or the teacher. The problems in this section have been created using Pythagorean triples, so there will be no radical values. Use this program to learn relationships, but make sure you do your homework so that you can graph equations that have radicals. This is a part of How-To philosophy. The activities are made to be straightforward so that students do not get bogged down in arithmetic, but learn the concept that's being introduced at the particular time, and not be dissuaded by having to add up complicated 3- and 4-digit numbers. Now, in this particular problem, the teacher can say, I would like to just concentrate on graphs of circles, parabolas, ellipses. We randomly got an ellipse this time. Let me show you how interactive Howe-Two Software is. Each activity has been made so that the student's interaction would be what it would be if a teacher were tutoring one-on-one and trying to talk the student through a particular skill. Here comes the instructions. Click on the location of the center of this ellipse. Now, the teacher has probably explained this in class, and about half the class has understood it, but the other half hasn't. So when they're in the lab or in a classroom and sent to the board, an interactive board, the student can be prompted as to what he needs to do. The center would be located based upon this factor, and it would really be at -3, 3. But say the student doesn't quite get it and thinks it's 3, -3, 1, 2, 3, 1, 2, 3, and he clicks. It says that's not the center. And he may ask his neighbor or ask the teacher until he gets help, or he may be just confirmed that he did know where the center was. So once he clicks on that, the center is confirmed. Now click on each point on the end of the major axis. Perhaps the teacher will show the whole class 1 or 2 problems and then let the kids solo flight on their own use of the activities. We find at my high school that students learn very quickly, and lots of times their response is, how do students learn this without this software? Now, the major axis is here because of the 100 being larger and it would be in the x direction, so it would be 10, so that the child doesn't get bogged down in counting. I have put 5, 10, 5, 10, so that it's easy to count out the 10. And now click on the instructions change. Now click on each point on the end of the minor axis. 6 and -6, 2, 4, 6, 2, 4, 6. Oh, I must have counted wrong. 2, 4, 6. Once those 4 reference points are in place, the software graphs the ellipse and then asks for the focus. This is where the Pythagorean triples come in, because the student will be taught that the focus, that there's a relationship between A, B, and C, the focal length of this figure, and in this case it's going to be 8 and 8. And now the graph is complete. This is the sort of thing a teacher would do if they were one-on-one with a student trying to teach them how to graph. Yet the software is doing exactly the same steps, trying to reinforce the learning with the student. Notice how different this would be from presenting a student with this equation and a multiple choice of 4 graphs, which of the following is the correct graph. You can see how interactive Howe-Two software is. That's because each activity was designed for a specific learning. When we close out of this, we go back to the menu for advanced algebra, and you can see the number of activities, advanced activities. We go back to the main menu. If we were looking for algebra with 2 unknowns, something simpler, and we wanted to have students learn how to graph y equals mx plus b, we go graph equals y equals mx plus b, and we can see, let's see, present a new problem. The student is presented with an equation. He has to locate the y-intercept, 1, 2, 3, 4, and then the correct slope, 1, 2, 3, 4, 1, 2, 3. You can see how quickly an Algebra 1 student could be reinforced in his ability to graph. It is not multiple choice, except in a few activities where we're trying to do summaries or cumulative assessments or something. Anything that says quiz is a self-grading quiz, and these can be used for a teacher who wants to get some sort of feedback with a little pain on their part. There's some simple equations. If it says quiz, the student types in their name, and then they hit begin, and they're given an equation. They put the answer in. When this gets checked, the quiz comes with the student's name, and if they say actual quiz, it comes out of the printer graded. Whenever there's a quiz, there's some sort of basic skill that the teacher can have an infinite number of computers, because these problems are randomly generated by the computer, and every student in the class would have a different quiz, and the computer would do the grading. And there's usually some extra thing involved in each program for enrichment of mathematics. There are a lot of activities that are called just mathematical activities. This is what to do with a student who you don't want to use as a tutor for his neighbor, but you want to give him something meaningful to do while the rest of the class has more practice. Mathematical activities can meet that need. There are a lot of topics in mathematics that we don't have time to deal with. Various rotational translation, symmetry, fractals, the Sierpinski's triangle, there's the Tower of Hanoi. They're just a variety of activities that the teacher can use to supplement the education of their brighter students. I've had students that have said to me that they were going to deal with fractals. They're going to study fractals because I showed them this in the lab, and they didn't have any knowledge of it, but when they came to the lab they would practice, and they picked their college based on whether the school had a department where they could study fractal mathematics. There are some things that are tied to geometry, optical illusions, painting with light in this computer age, how colors are formed with the RGB combination of light. I made this actually for myself so that I could get the colors that I wanted for backgrounds. You put in the particular component of red, and you can see how actually light combines. This also be helpful for optics, for physics, which combination, and when we're doing a web page, if you use these hexadecimal numbers, you would get the particular color that you see here on your web page. Or in VB programming, is like I do, we have to use the decimal equivalents. So this shows the relationship of the RGB. This is something that's not part of our curriculum, but is part of our culture. And a student can have an opportunity to learn this sort of mathematics, which would be a part of many of their lives in the future. But it's not in the curriculum now, but it's supplemental activities. Let's take a look at the primary menus. We see here that we have application problems. This would be like bowling score, magic squares, or bowling scores, percent word problems to making a change. Let's look at the magic square. This is a way of practicing mental math without just the tedium of all those timed quizzes. Press new problem. It says each row and column totals 24. So the student can see that this row totals 24. This one has to do 24. So he has to do the mental math to figure out what the missing term would be. If he chooses incorrectly and pushes enter, he gets a signal that it was wrong, and he pushes 8, it's going to turn black, and it's going to be correct. So then 9 is 17 and 7. So you can see the mental math that would be involved in completing the magic square, which give practice to a student without some of the just a little bit more fun. If it was a more advanced group, you could allow negatives. In the high school, the magic squares automatically mix in sign numbers, positives and negatives, but in the primary, the negatives are a selection that you might introduce to your brightest students. This Mastering Mathematics has 8 activities. It was really originally designed for our high school proficiency, but I include it here in the primary, and it has lots of activities built in. Place value, adding and subtracting, multiplying, fractions, word problems, improper fractions, something that people have asked for. When I first started developing primary activities, it was because of a request of one of our neighboring school systems. They said, we need stuff for elementary, your high school stuff is so good, and so they gave me a list, and I tried to program the things that they requested. But at the top of their list was telling time, and they wanted an analog clock, analog digital clock. This is a first activity just to create a clock, and it's pretty self-explanatory. You click and you place the number where you think it should belong, and when you press check, if it's correct, it stays gray. If it's incorrect, turns red, and then you have to go put in the right clock. Keep working at it till you get your clock created. You can see that it's not beating up the kid with how many things they've gotten wrong. They just keep working till they succeed. Now let's go to learning to tell time. Here's what they really requested, was an analog and digital clock the teacher could use to explain how the clocks work, and you can stop the clock at any time and start it up and discuss with students the placement of the hands. And then you can click on the activity and it'll say set the clock to 4:45, something like that, and you can take them around and set the clock and then check. I will say correct or incorrect. This is one direction from digital to analog. Then there's another activity which is analog to digital, and this was requested by our neighboring teachers. I hope that it turned out to be what they wanted. You can see how this is driven from these menus. I wanted to explain to the installers of the programs how the programs are set up. It looks like I've gotten out of the main directory here. So let me see if I can get there again. I'm looking for Howe-Two current packages. When you install this software, you install the primary software or the Howe-Two by course for the high school and middle school. And then what you want to do is either put these files on a server, then create a shortcut to the menu programs and put that usually on the desktop. Like inside of Howe-Two by course, there is a file called courses, and let's see if I can find that. And you create a shortcut to that. Don't drag it, but create a shortcut to it. And then pull that shortcut out on the desktop. And then the students can, or the teacher can then bring up the program menu in that way. So there'd be this one for the high school menu, and then there would be Howe-Two Light, which would be what you would want for middle school, and the courses, the primary menu for middle school, for elementary. And then you just access these shortcuts and make Howe-Two software available to your classes. I hope this explanation has been helpful. Thank you.